Hi guys, welcome back to my channel. In our previous classes, we've actually seen how the Maclaurin series formula was derived, and we've been able to use the Maclaurin series formula to find the series expansion of some functions. And I actually listed these functions today where we worked with the natural log of 1 plus x, and we're able to derive this using the Maclaurin series formula. This is for sine x, this is for cos x, and this is for exponential x. So in today's class, we're going to be using the series expansion of this standard function to find the Maclaurin series expansion of some compound functions. So for today, we're going to be working on just 2 questions, and in subsequent classes, we're going to be exploring other questions. So now let's get to it. Now for the exercises we're working today, like I mentioned, is just 2. The first one, we have given that terms in x to the power n with n greater than 4 may be neglected. Now use the series expansion of exponential x and sine x to show that exponential sine x is approximately 1 plus x squared over 2 minus x to the power 4 over 8. And the next one says, find the first 3 non-zero terms in the series expansion of the natural log of root 1 plus 2x over 1 minus 3x. Now, for these particular questions, we can see that we're going to be needing the series expansion of exponential x, sine x, and we're going to be needing for natural log of 1 plus x. So now let's start with the first question. So for number 1, we're given exponential sine x. We are asked to find the series expansion of this. So but before we get into this, I would love us to bring in the series expansion of sine x and also bring in the series expansion of exponential x. So let's get the instruction here. It says, given that terms in x to the power n with n greater than 4 may be neglected. So what it means is the powers of x, that's the powers of x, which is actually ranging from probably 0, 1, 2, 3, 4, and all that. So now when we get to the one greater than 4, that's probably x to the power 5, x to the power 6. So if n becomes greater than 4, so if the powers of x become greater than 4, we should neglect it. So what I mean is, if we're going to be writing the series expansion of exponential x and sine x, we're going to be writing the values of the powers of x from 0 to 4, depending on the powers we have there, but it must stop at 4 and must not exceed 4. So we're not going to be using the powers of x ranging from 5, 6, 7, and so on and so forth. Now, coming to this place, we'll have the sine x to be this, and then we'll have for exponential x to be this. So for sine x, we're going to be writing x minus x cubed over 3 factorial. That is it. We're not going to work with x to the power 5 because it is now greater than 4. So we're going to write just this 2. Then for exponential x, we're going to be writing, we're going to write all of this because it actually has it actually stops at x to the power 4. So if we actually added the next term, which is x raised to the power 5 over 5 factorial, it won't be needed because it says we must neglect n greater than 4. Now let's get to it. So recall, from our series expansion, exponential x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x raised to the power 4 over 4 factorial plus dot dot dot, it goes to infinity. And then for sine x, like I said, we just write the first 2 terms. So for sine x, we have x minus x cubed over 3 factorial plus dot dot dot. Okay, now, so the question we have there says exponential sine x. So now we'll have exponential sine x, which is going to be equal to exponential. So we're going to replace sine x with the series expansion of that. So the series expansion of sine x we have is this. So replacing sine x with all this, we'll have exponential x minus x cubed over 3 factorial plus dot dot dot. We'll close that up. Now, I want us to recall that in indices, we're going to be referencing some ideas from indices. So in indices, we know that x to the power a times x to the power b is equal to x to the power ab. So in this case, I'm going to bring this idea up for this exponential, so we can clear the brackets we have there. So this becomes exponential x times exponential minus x cubed over 3 factorial. Exponential minus x cubed over 3 factorial times dot dot dot, because we are actually taking it to infinity, so you have to keep that in mind. So the next thing we have to now bring in is that, so since we've been able to actually clear the bracket at the top and we are left with exponential x times exponential minus x cubed over 3 factorial. So now we have to now bring in the series expansion of exponential x. This is the series expansion of exponential x. So what we're going to be doing is pretty simple, but let's do that on the next slide. So now, I hope we remember that exponential x is equal to what we have at the top, all this. So what we're going to do is, we have exponential x here. I'm going to bring that now times exponential minus x cubed over 3 factorial. Minus x cubed over 3 factorial. So what I mean is, anywhere we see x, we're going to substitute x, and we're going to substitute minus x cubed over 3 factorial in there. So here we have x. I'm going to be changing it to minus x cubed over 3 factorial. Here I have x. I'm going to do the same, and so on and so forth. So, but let's start from this. So for this, we're going to replace it with the series expansion of exponential x, because that's what we have there. So that gives us 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the power 4 over 4 factorial plus dot dot dot. So we're going to put this in the brackets, and then we'll have times the next thing, exponential minus x cubed over 3 factorial. So the first thing we'll have there is 1, then plus, so like I said, we're going to be substituting. So instead of x, I'm going to have minus x cubed over 3 factorial. Then this has to go dot dot dot. The reason why we are stopping here is because if I decide to substitute minus x cubed over 3 factorial for x squared, that's substituting x here, it now becomes, let me write that, it now becomes minus x cubed over 3 factorial. Then you know our x is actually, as in everything has to be squared. Everything has to be squared, and then it now has to be over 2 factorial, but we are not really interested in the factorials. Now, if everything has to be squared, that means 3 times 2 becomes 6. So it has exceeded the instruction there that n should be neglected if it is greater than 4. So that is why we are going to stop here. We're not going to go with the next term. Okay? Now, this is what we have. So what I'm going to do now is, we have to start clearing this bracket. We have to start multiplying. We have to multiply. We have to multiply this by this. So let's start with the first thing we have. We have 1 times 1, which is 1, plus we have x times 1. That's, I want to use all this term to multiply the first term here. Then afterwards, we use all this term again to multiply the second term. So we're starting with the first term. So we have 1 times 1 plus x times 1 plus x squared over 2 factorial times 1. Then we have plus x cubed over 3 factorial times 1, which is the same as x cubed over 3 factorial. We have plus x raised to the power 4 over 4 factorial times 1, which is the same as x to the power 4 over 4 factorial. So now we're done with the first term. We've multiplied all we have here with the first term. So we're moving to the second term. So the next one for the second term is this. So it becomes 1 times minus x cubed over 3 factorial. 1 times minus x cubed over 3 factorial becomes minus x cubed over 3 factorial. Then the next is x times x times minus x cubed over 3 factorial. That should give us minus x to the power 4 over 3 factorial. So we're going to stop here because if I do x squared over 2 factorial times minus x cubed over 3 factorial indices, we'll multiply the x squared times minus x cubed. That will give us minus x to the power 5. Now it has exceeded n greater than 4. So we are actually stopping here, but then we have to bring in our plus dot dot dot. Now I want to okay, we can see that x cubed over 3 factorial minus x cubed over 3 factorial is 0, so that is gone. Then I'm going to bring this together and work with it because they are like term. X to the power 4 over 4 factorial minus x to the power 4 over 3 factorial. But before then, let us deal with the factorial. So this becomes 1 plus x squared over 2 plus x raised to the power 4 over 24 minus x to the power 4 over 6 plus dot dot dot. Now, this leaves us with, we have 1 plus x squared over 2 plus, now x raised to the power 4 over 24 minus x raised to the power 4 over 6. When we simplify that, it gives us x raised to the power 4 over 8. So exponential, thus exponential sine x is equal to, we have 1 plus x squared over 2 minus x to the power 4 over 8 plus dot dot dot. But you know, we are actually asked to ignore anything n greater than 4. So we have to stop this continuation because we are actually ignoring them. So that gives us, so now it becomes approximately 1 plus x squared over 2 minus x to the power 4 over 8. So the number one question has been answered. Let's check that. It says, given that terms in x to the power n with n greater than 4 may be neglected, use the series expansion for exponential x and sine x to show that exponential sine x is approximately 1 plus x squared over 2 minus x to the power 4 over 8, which is what we'll have here. So for number 2, it says find the first 3 non-zero terms in the series expansion of natural log of root 1 plus 2x over 1 minus 3x. So we are looking for the first 3 non-zero terms, the first 3. So the first 3, let's take note of that instruction. So number 2, we'll have the natural log of root 1 minus 2x, no, 1 plus 2x over 1 minus 3x. So this is the question given in number 2, and we are asked to find the first 3 non-zero terms. So to solve this problem, we are going to be introducing one of the laws of logarithm. We'll have, in logarithm, so we're going to be introducing that if we have log a divided by b, it means log a minus log b. Okay, so in this case we'll have our division sign here. This is our division, so we'll be having the natural log of root 1 plus 2x over 1 minus 3x. We're going to express this as the natural log of root 1 plus 2x minus the natural log of 1 minus 3x. Okay, this is what we'll have. Now we'll have square roots here, so I'm going to express the square root as a power. It becomes the natural log of 1 plus 2x power half. Okay, so half means square root, power half means square root. Now we have minus natural log of 1 minus 3x. Now another law of logarithm is the power law. So if we have something like log b to the power c, it can be expressed as c log b. So in this case, this power half here, we put it to the back, we express it as 1 over 2 natural log of 1 plus 2x minus, let's erase this, minus the natural log of 1 minus 3x. Okay, so this is what we'll have when we express this. We're going to get this. So from here onwards, we can now introduce a series expansion of 1 plus x to actually expand to find the series of the natural log of root 1 plus 2x over 1 minus 3x. So we have to recall that the natural log of 1 plus x is equal to, we have x minus x squared over 2 plus x cubed over 3 minus x to the power 4 over 4 plus dot dot dot. So what we'll have is that the natural log of root 1 plus 2x over 1 minus 3x is equal to so it becomes 1 over 2. Now, the natural log of 1 plus x is equal to x minus x squared over 2 plus x cubed over 3 minus x to the power 4 over 4. So we can see that this x here are reflecting here, 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 and here. Now in this case, we still have the 1 plus 2x. So 1 plus x, but here 1 plus 2x. So what I mean is, anywhere I see x here, I'm going to be substituting 2x into that. Anywhere we see x in this expansion, we're going to be substituting 2x into that. And for the denominator here, anywhere I see x here, we're going to be substituting minus 3x into that. Anywhere we see x, we're going to be substituting minus 3x into that. But then let's not forget, the question says that we should work with the first 3 terms. The first 3 terms, this part, since we're working with the first 3, so the first 3 is 1, 2, 3. So then we'll have a minus dot dot dot. So that is it. Now substituting the numerator, which is we are not working with this side, so we're working with this side. So we have 1 over 2, the natural log of 1 plus 2x. So we are substituting 2x into any part we see x here. So we're going to open a bracket for that. Now x, in this case, I'll put 2x minus x squared, that will be 2x squared over 2, then plus x cubed, that will be 2x cubed over 3, then we have the minus dot dot dot. We'll close this bracket, then we have minus the natural log of 1 minus 3x. So we have minus the natural log of 1 minus 3x. So we are going to be substituting minus 3x into anywhere we see x in the series expansion of 1 plus x. That being said, we'll be having x there, so it becomes minus 3x. Then the next is minus, then we'll have minus 3x squared over 2. Then we'll have plus minus 3x cubed over 3 minus dot dot dot. Okay, I hope we are actually getting this. Now working with this, we'll be having, okay, 1 over 2 bracket 2x minus, we have 4x squared over 2. We have plus 2 cubed is 8x cubed over 3 minus dot dot dot. Then for this part we have minus, open the brackets for the natural log of 1 minus 3x. This will give us minus 3x. Then minus 3 squared is 9. Then we have minus 9x squared over 2. Then minus 3 cubed is minus 27. Then we'll have minus 27x cubed over 3 minus dot dot dot. So this is what we have now. So we're just going to express further and get our final answer. So let's work on this in the next slide. So now if we look, we can see that we have 1 over 2 here. So 1 over 2 multiplied by everything we have inside here. For the first part, we have 2 divided by this 2 here. So that's 2 times 1 over 2 gives us just x there. Then in this case, we have 4 over 2 multiplied by this half. That's 4 over 4. So 4 divided by 4 is 1. So we have a minus x squared. Then here, 2 here 1. And 2 in 8 is 4. So that will leave us with plus 4x cubed over 3 minus dot dot dot. Then clearing this bracket, this will give us minus times minus 3x gives us plus 3x. Minus times minus 9x squared over 2 gives us plus 9x squared over 2. And then minus times minus here gives us plus 27. Okay, 27 divided by 3 gives us 9. So that's plus 9x cubed minus dot dot dot. Okay, so we're going to be collecting like term here. So now let's collect like term. We can see this and 3x, these are like term. And then we have minus x squared, we have this, and we have this. So bringing them together, that leaves us with x plus 3x minus x squared plus 9x squared over 2 plus 4x cubed over 3 plus 9x cubed. Then we have minus dot dot dot. So that way we'll have that x plus 3x gives us 4x. Then minus, okay, let's put 1 here. So minus 1x squared plus 9 over 2x squared. That's minus 1 plus 9 over 2 gives us plus 7 over 2. So plus 7 over 2x squared. So we are left with 4 over 3 x cubed plus 9x cubed. Now 4 over 3 plus 9 gives us plus 31 over 3. Then we'll have x cubed. So plus 31 over 3 x cubed plus dot dot dot. This actually goes to infinity. So now the question says find the first 3 non-zero terms. The first 3 non-zero terms we have 1, 2, 3. So this is actually the answer. So when we expand this, so when we expand the natural log of root 1 plus 2x over 1 minus 3x, this is actually what we get. So we've been able to do justice to the 2 questions we attempted today, but then we should look out for more Maclaurin series expansions. So we're going to be looking at maybe more complex functions to tackle together. So let's be on the watch out for my next video. Thank you very much for those of you that joined me from the beginning till this point. It actually means the whole world to me that you decide to give me your time and spend it learning mathematics with me. So if you actually have friends that find Maclaurin series difficult, you can do well to share this video with them. And don't forget to like, subscribe, and drop a comment if you actually enjoyed today's class. Thank you very much and see you in my next video. Bye!